In section 7.5 example 2, what we've got here, we've got a set of parallel plates, and just keep in mind parallel plates really are like two big sheets of paper. So when I draw it, this is kind of like the edge of the sheet of paper, but this sheet of paper kind of goes in this way. I can't, my drawing skills aren't that good. We are told we've got a set of parallel plates. We've got some charged particle that's balanced here in between. Okay, so here's the particle. It's balanced between. Now, we don't know the charge of this particle. That's kind of what we're being asked for in part A. We are told, though, that the electric field is up. So we know the value, but the electric field is going up. Okay, so electric field, let's point it that way. There's electric field. Electric field, just remember, always points from positives towards negatives. Okay, so what that means is they're kind of telling us in a tricky way that the positive plate is on the bottom, the negative plate is on the top. So in part A of this, it's does this particle have a net positive or negative charge? Remember what's happening here, if I can draw a little free body diagram, gravity is pulling this thing down. This is kind of like the Millikan experiment that we were just doing. Gravity is pulling it down. I need the electric force to be pulling it up, Fe. Those are terrible arrows, but you know what I'm saying. In order for this guy to be attracted to the top one, it must be positive. It's also going to be repelled by the bottom one. That's going to give us this electric force being up. Okay, so what we're figuring out then is for part A, does it have a net positive or negative charge? It's got to be positive. And whoops, it's got to be positive because we need the electric force to be up in this case to balance that downwards force. Because the field is up, that tells us it's positive plate on the bottom, negative plate on the top, which means this guy's got to be positive in order to be attracted to the positive plate on top and repelled by the negative plate on top and the positive on the bottom. Okay, so for part B, here's the math. What we're looking for is Q. Okay, so how many extra protons or electrons does it have? We know, we just kind of figured out in the last example, Q is equal to Ne. So I'd like to know, actually we're not trying to find Q, we're actually trying to find N. So let's squeak that in here, what's N? But in order to find N, I'm gonna find Q. Okay, so what we know is, if you can see my little free body diagram, those two forces are equal. So Fe is equal to Fg, okay? We saw this in the last example where force acting on that charged particle is Q times the field that it sits in. This field is all the way across, by the way. I'm just not drawing it so I can get my other drawings in here. Fg is mg. We know the field. The field is 110 newtons. I don't know this Q value. We do know the mass, so 5.3, 10 to the minus 8. That's a decimal there. And we do know little g is 9.8. Okay, so we're looking for Q. We can go through and solve for Q on its own. You could also sub Q equals Ne in here and then sort of solve directly for N. I'll solve for Q first. If I rearrange and solve for Q, we get 4.7 times 10 to the minus 9 coulombs. Again, that's not what we're looking for. I now need to use this, Q equals Ne, and hopefully you can see that. This here is 4.7 times 10 to the minus 9. N is what I'm looking for. Remember, the elementary charge is always just this, whether we're talking about protons or electrons, 1.6 times 10 to the minus 19. And I can rearrange that, and with sig digs, I get 2.9 times 10 to the 10. Because this is a positive charge, so it kind of says how many extra protons or electrons. Because it's a positive charge, I've lost electrons. So you could say it's a deficit of electrons. That gives me a positive charge. Or you could say, that's an or, excess protons. Again, some people don't like to talk about protons because the protons are always fixed in place. I can't gain or lose protons. I can only gain or lose electrons. So some people will say that's kind of the better answer. Either is fine with me, but just so you know, when you go to university, sometimes people focus on electrons.